Hello everyone, welcome to my channel. This is my very first video and I'm excited to start this learning journey with you guys. On this channel, I'll be sharing chemistry topics or concepts in a simple and easy to understand way. If you are interested in learning chemistry in a simple way, make sure to stay tuned for future videos. Since this is my first video, thank you for joining me. In today's video, we're going to learn about the SN1 substitution reaction, an important organic chemistry reaction that frequently appears in exams and help us understand reaction mechanisms. Now let's get started with today's topic, the SN1 reaction. What does SN1 stand for? How does this reaction occur, and why is it called a unimolecular nucleophilic substitution reaction? Let's find out step by step. So SN stands for S for substitution, N for nucleophilic, and 1 means a unimolecular reaction. Substitution means one group on a molecule is replaced by another group. Nucleophilic means the replacing species is a nucleophile, meaning it will donate an electron pair. Unimolecular means one, the rate determining step involves only one molecule. So this reaction happens in two main steps. Number one is in which the carbocation is formed, and this is the slowest step, which is the rate determining step. The second one is the attack of nucleophile. So number one is formation of carbocation. Number two is attack of nucleophile. Let's understand it with an example. So we have our X group here. R means alkyl group and X mean halide group. Halide can be chlorine, bromine, iodine, fluorine. This could be anything from these four, and alkyl group is mainly the carbon chain. And we have a nucleophile. Imagine we have a carbon atom attached to a leaving group, and the leaving group could be anything, which is the halide group, chlorine, bromine, iodine, fluorine. Imagine we have a bromine. The bromine breaks away and takes the bonding electrons with it. This leaves behind a positively charged carbon, which is called a carbocation. And X will leave as a leaving group. This step is slow and requires energy, so it is the rate determining step, which is called RDS. Since only the substrate molecule is involved in this slow step, this reaction is called unimolecular reaction, and this is the step number one, the formation of carbocation. Now comes the step number two, the attack of the nucleophile. Now the carbocation is electron deficient and is highly reactive. The nucleophile sees this as positive charge and quickly attacks the carbon. Now the nucleophile will attack on this one, and a new bond forms replacing the group that left earlier. Let's say we have water as a nucleophile here, and this will attack on the carbocation and form a new bond, which is ROH, and X will leave as HX. This is the second step, which is the attack of nucleophile, and that is why it is called substitution reaction, because one group substitute with another one. There is one more important point about the R group, means the carbon atoms. This reaction prefers tertiary carbons because they form more stable carbocations, and the more stable the carbocation, the easier it is for the leaving group to leave. That's why SN1 reactions are commonly seen with tertiary alkyl halides. So they are more common in 3 degree, then 2 degree, then 1. They prefer mostly tertiary groups, then secondary, then primary. Now let's take an example to understand it more deeply. For example, we have CH3 with chlorine. Now this bond will break and chlorine will be left as negative charge, and this is the leaving group. Chlorine is acting as leaving group. Now the first step includes the formation of carbocation, and the carbon group will form as CH3 negative. Now comes the second step, which is the attack of nucleophile. For example, we have this group as carbocation. Now the nucleophile, which is water, will attack on this carbon atom and form a bond with it. And Cl will leave as HCl. Example is the hydrolysis of alkyl halide, and this happens in two steps, which is the formation of carbocation and attack of nucleophile. The first step is the carbocation formation, which is the slowest step, and it is actually the arduous step. Only one molecule of the substrate is included in the formation of carbocation. The nucleophile will attack on the carbocation and form the resultant product. This is the SN1 substitution reaction, which happens in two steps. Group substitute with another one. Think of it like leave first and attack later. The key point is to remember that the slow rate determining step involves only one molecule, which is why it's called unimolecular. If you understand the formation of carbocation, you have understood the heart of the SN1 mechanism. Now thanks for watching, and remember substitution, nucleophilic, unimolecular. If this explanation helped, don't forget to like, share and subscribe for more easy chemistry lessons. So see you in the next video. Bye bye.